Welcome back to the World Model Podcast. In today's episode, we'll be discussing the dream within a dream, recursive simulation and its stability. A world model runs a simulation, but what if the simulation itself contains an agent running a world model? This is recursive simulation, a simulated entity inside a simulation running its own internal simulation to make decisions. Think of it as a dream within a dream. Today we ask, does this recursion hold? Or does it inevitably collapse into nonsense, like a hall of mirrors that eventually distorts the image into noise? This isn't just a thought experiment, it's a computational stability problem. If our world model, level 1, is simulating a robot, and that robot's AI uses a simpler world model, level 2, to plan, then level 1 must simulate not just the robot's actions, but the computational process of level 2's planning. Level 1 is now simulating a simulation. The deeper the recursion, the more computational burden, and the greater the risk of error amplification. Tiny inaccuracies in level 1's physics get modelled by level 2's world model as fundamental laws, which then lead to level 2's agent to make decisions based on flawed reality. When level 1 enacts those decisions in its more accurate physics, the results could be wildly off. The dream becomes a fever dream. Yet, recursion might be necessary for true sophistication. Human consciousness is arguably recursive. We are beings who model the world, and we know that we model the world and we model other beings who are modeling the world. Our social reality is built on these nested models. For an AI to operate in a human-like society, it may need stable recursion. The breakthrough will be fixed point recursion, a mathematical state where the model's simulation of a submodel converges to a stable, accurate representation. It's the equivalent of a mirror reflecting a mirror. But finding an angle where the infinite reflection resolves into a single clear image. Achieving this would be a landmark, allowing for the simulation of truly sophisticated, self-reflective agents. My controversial take is this. The stability of recursive simulation is the final test for a world model's claim to be a true reality engine. If we can only simulate simple reactive agents, it's a physics simulator. If we can stably simulate agents that are themselves running sophisticated simulations, agents that think as deeply as we do, then it has crossed a threshold. It's not just simulating a world, it's simulating minds within that world. And that is the foundational technology for a genuine digital existence, a true metaverse that is more than a fancy video game. This has been the World Model Podcast. We don't just simulate worlds, we probe the depth at which worlds can contain other thinking worlds. Subscribe now.